Welcome to solverfy.
So there's 4 parts to this problem. In the first part, we're asked to find the mass of 2.50 times 10 to the negative 3 moles of ammonium phosphate. So ammonium phosphate, ammonium is an NH4, phosphate is PO4. The PO4 has a 3- charge, NH3 has a +1 charge. So you would need 3 NH3s to balance out the -3 from the PO4. So let's find the molar mass of ammonium phosphate, and then all we would have to do is multiply. And so there's 3 nitrogens. Nitrogen has a molar mass of 14.01. There's 3 times 4, 12 hydrogens, 1.008. There's 1 phosphorus, 30.97. And there's 4 oxygens, 16.00. So we can multiply all these together. 3 times 14.01 plus 12 times 1.008 plus 30.97 plus 4 times 16. And you would get a molar mass of 149.10 grams per mole. And now all you'd have to do is multiply by this original number of moles. So 2 times 2.5 times 10 to the negative 3. And the mass of this sample would be 0.373 grams. Okay. Yeah, and we need 3 sig figs because the least number of sig figs we have are from the original number of moles, which has 3 significant figures here. Let's look at part 2. We're asked to find how many moles of chloride ions are in moles Cl minus in 0.2550 grams of aluminum chloride. Aluminum +3 charge, chloride has a minus, and so you would need 3 chlorines to balance this out. So let's find the molar mass of aluminum trichloride. Molar mass of aluminum is 26.98, and there's one of them, plus 33 times 35.45 for the chlorine, 26.98 plus 3 times 35.45 is 133.33 grams per mole. So we multiply this by, we take 0.255 grams and we multiply this by 1 mole AlCl3 per 133.33 grams of AlCl3. And then we multiply how many chloride ions per aluminum trichloride. That's 3. So 3 moles of Cl minus per 1 mole of AlCl3. These cancel, and this equals 0.225 divided by 133.33 times 3, and you would get 5.063 times 10 to the negative 3 moles of Cl minus. Let's look at part C. In this part, we're looking at the mass of 7.70 times 10 to the 20th molecules of caffeine, which is C8 H10 N4O2. So, like always, we need to first find the molar mass of the molecule we're looking at. So the molar mass of caffeine, there's 8 carbons. Each one has a molar mass of 12.01, plus 10 hydrogens. Each one has a molar mass of 1.008, plus 4 nitrogens. Each one has a mass of 14.01. And then 2 oxygens, which each have a molar mass of 16.00. 8 times 12.06 plus 10 times 1.008 plus 4 times 14.01 plus 2 times 16 is 194.2 grams per mole. Okay, so now that we have the molar mass, we need to find out how many moles 7.70 times 10 to the 20th molecules corresponds to. Okay, and this we use Avogadro's constant, so 1 mole is 6.022 times 10 to the 23rd molecules. Okay, and then now these cancel. We have 194.2 grams per mole. These cancel. And so if we multiply all of these together, we get the mass in grams. So 7.70 times 10 to the 20th divided by 6.022 times 10 to the 23rd gives you the number of moles that you're dealing with times 194.2 grams per mole equals 0.248 grams. And make sure the number of sig figs is correct. You always look at the one with the least number of sig figs when you're multiplying, which in this case is 7.70 with 3. So our answer is 0.248 grams. Finally, let's look at part D. We're asking for the mass of cholesterol if 0.00105 moles has a mass of 0.406 grams. So really, for this one, we don't actually need to find the molar mass. All we need to do is remember what the definition of molar mass is. So molar mass is the grams per 1 mole of a compound. And so if we know how many grams are in 0.00105 moles, then we can set up a simple equation to find out. There'd be x grams in 1 mole. And so all you'd have to do is take 0.406 divided by 0.00105 moles, and you would get 386.66 repeating moles. Okay, we only have 3 sig figs here, so we round this up to 387 grams per mole. And if you're curious, you can look up the molar mass of cholesterol, and it turns out that it does in fact have a molar mass of 286.65, which is very close to our number that we got before we rounded it up. So that's the problem.